stop being someone who wants to code and start being someone who does. Welcome back to Pareto Code. Today, we're grabbing the keys, turning the ignition, and learning how to actually drive. By the end of this video, you will have seen and understood your very first Java program. But more importantly, you'll understand the entire lifecycle of your code, from a simple text file to a compiled program to something the computer can actually execute. Now, we're going to cover a lot, from strange acronyms like JDK and JRE to the 3 types of errors every single developer encounters. But don't worry, we're going to break it all down, step by step, into a clear and simple guide. This is the most important step in your entire journey. Are you ready? Let's dive in. So, what exactly is Java? It was developed back in the early 90s by a team at Sun Microsystems, which is now owned by Oracle. And fun fact, its original purpose was to run on embedded chips inside consumer electronics. Think smart appliances. But in 1995, it was redesigned for developing web applications, and it exploded in popularity. Why? Well, its rise to fame can be traced back to one powerful promise: write once, run anywhere. See, Java was designed to be simple, secure, and most importantly, portable. It's a full-featured, general-purpose language used to build robust, mission-critical applications. And today, it is everywhere. More than 3 billion devices run Java. It's used on desktops, on massive web servers, and on mobile devices. Most major companies use it. The software for Android phones is built using Java. It was even used to write the code that controlled the robotic rover on Mars. So when you learn Java, you are learning one of the most established and powerful programming languages on the planet. Before we write our first program, we need to quickly understand a few key terms. It can feel a bit like alphabet soup at first, but I promise it's straightforward. First, you'll hear about the Java language specification. This is just the official rulebook. It defines the syntax and grammar of the language. Next, and more importantly, is the API, which stands for Application Program Interface. The best way to think of the API is as a huge library of pre-written code. It's a massive collection of ready-to-use tools and components that we can use in our own programs, so we don't have to build everything from scratch. And finally, you'll hear about the JDK and the JRE. The JDK, or Java Development Kit, is the whole workshop. It contains all the tools you need to write and compile your Java programs. Inside the JDK is the JRE, or Java Runtime Environment. The JRE is what you need to simply run a Java program. Your computer needs the JRE to run Java applications. But you, the developer, need the entire JDK to create them. Now you could just use the command line tools that come with the JDK. But most developers use an IDE, which is an integrated development environment. An IDE is a single application that bundles everything together: a text editor, the compiler, a debugger, all in one user-friendly interface. We'll be using one of those very soon. Alright, enough theory, let's look at some actual code. Here is a simple program that just displays the message, "Welcome to Java," on the screen. Let's break it down line by line. First, public class welcome. Every Java program must have at least one class. For now, just think of a class as a container or a blueprint for our program. We've named ours welcome. Next is the big one: public, static, void, main. And then inside the parentheses, it takes one argument, string, with square brackets, args. This entire line is the front door to our program. This is the main method, and it's the official starting point. When we tell Java to run our code, this is the very first place it looks. For now, don't worry about the words public, static, or void. We will cover all of that later. Just remember that main is where the execution begins. Inside the main method, we have a comment. Anything after 2 slashes is a comment. It's just a note for humans to read. The compiler completely ignores it. And finally, our one and only instruction: System.out.println, and inside the parentheses, in double quotes, our message, "Welcome to Java." This statement is pretty readable. It tells the system to go out to the console and print a line of text. The text we want to print is a string of characters, which must be enclosed in double quotes. You'll also notice a few special characters. The curly braces, that's the squiggly brackets, create a block that groups code together. The welcome class has a block, and the main method has its own block inside it. And at the end of our statement, there's a semicolon. That's the little dot and comma. Think of this as a period at the end of a sentence. It tells Java that an instruction is complete. Forgetting the semicolon is one of the most common errors for beginners. And that's it. A class to hold everything, a main method to start everything, and a single statement to do the work. We can even extend this easily to print 3 messages or to do math just by adding more System.out.println statements. So how do we get from that source code file to a running program? It's a 3-step dance: create, compile, and execute. Step 1. Create. We write our human-readable code and save it in a file with a .java extension. In this case, welcome.java. Step 2. Compile. We use a tool from the JDK called the compiler to translate our source code. We type the command jvik welcome.java. If there are no syntax errors, the compiler creates a brand new file, welcome.class. This file doesn't contain source code. It contains something called Java bytecode. Now this bytecode is the secret to Java's write once, run anywhere power. It's not written for Windows or Mac or Linux. It's written for a conceptual machine, the Java Virtual Machine, or JVM. Step 3. Execute. The JVM is a program that acts as a universal translator. It reads the bytecode and translates it into the native machine language for whatever computer it's running on. We run it with the command java welcome. And that's when the JVM executes our code, and we finally see Welcome to Java appear on our screen. So, to recap, we write a .java file. We compile it into a .class file of bytecode, and the JVM runs that bytecode. Now don't worry, very soon we'll be using an IDE that handles all of this for us with the click of a button. But understanding this 3-step process is fundamental to knowing what's really happening under the hood. So now you know the complete life cycle of a Java program. But before we go any further, we need to talk about something just as important as making the code work: making the code readable. This is where programming style and documentation come in. Good programming style is all about reducing errors and making our code easy for ourselves and for others to maintain. First up, let's talk about comments. A comment is a note you leave in the code for a human to read. The compiler completely ignores them. Java has line comments, which start with 2 slashes, and block comments, which are enclosed in a /* and */. Next is indentation and spacing. Consistent indentation is crucial. It shows the structure of your code. When a piece of code is inside another block, you should indent it to show that relationship. It makes the code instantly easier to follow. Finally, there are different block styles, which refers to where you place your curly braces. The style you choose doesn't matter, but what does matter is that you pick one and use it consistently. No matter how clean your style is, when you're learning to program, you will make errors. It's a universal experience, and learning to fix them is a core skill. Programming errors generally fall into 3 categories. The first, and most common for beginners, are syntax errors. A syntax error is like a grammar mistake. It happens when you break the rules of the Java language. The compiler will detect these and tell you exactly where the problem is. The second type are runtime errors. A runtime error happens while your program is running. The program tries to do something impossible, like dividing by 0, which causes it to crash. The third, and most challenging type, are logic errors. A logic error is when your program runs perfectly, it doesn't crash, but it produces the wrong result. The code is syntactically correct, but the logic of the program is flawed. These are the sneakiest bugs. They're silent and they hide in plain sight. Let's look at the 4 most common mistakes that new programmers make. If you can keep these in mind, you'll save yourself a lot of headaches. First, missing braces. Every opening curly brace must have a matching closing brace. Second, missing semicolons. Every statement in Java must end with a semicolon. Third, missing quotation marks. A string of text must be surrounded by a pair of double quotes. And fourth, misspelling names. Remember, Java is case sensitive. Main with a lowercase m is completely different from main with a capital M. You will make all of these mistakes, I promise. But now you know what to look for. From the history of Java, to the structure of your first program, to the 3 types of programming errors, you now have the complete theoretical foundation for your journey. If you've made it this far, take a moment to appreciate it. You've officially taken your first, and often most difficult, step into the world of programming. You've peeked behind the curtain and seen how it all works. But theory is one thing, and practice is another. So if you're ready to make that leap from theory to practice, make sure you hit that subscribe button and ring the bell so you're the first to know when that video drops. And if this video helped you connect the dots, a quick click on the like button is always appreciated. It tells YouTube this is a valuable resource for new developers. Thanks for watching, and I'll see you in the code.